The carbonyl compounds F and G shown below contribute to the flavour of coffee. Part A. Compound F is a member of a homologous series. Part 1. Explain the term homologous series. So a homologous series will have the same functional group. So this would get you your first mark. Alternatively, you could say that it has similar chemical properties or reactions. Either one of these statements would get you the first mark for this question. And then we need to look at what makes them different in the series, and that's the fact that each member, or each successive or subsequent member, differs by CH2. The word successive or subsequent is key in this question, and the mark scheme has it in bold, so it's really important that you write it in your answer for this question. And then to get the 2 marks for this question, you get a mark for this first statement, so either same functional group or similar chemical properties / reactions. So either of those, that's your first mark, and then your second mark from saying each successive or subsequent member differs by CH2. Part 2. Predict the molecular formula for the member of this homologous series containing 24 carbon atoms. So, as we're told in part 1, F is a homologous series. So we're going to be looking at F and trying to work out its molecular formula when we have 24 carbon atoms. So the only bit in a homologous series that's going to differ is this CH2 group. We can expand it by adding more CH2s. So writing out what's not going to change, we have C4H8O. So that's just all of this excess here, because this group won't change and this aldehyde functional group won't change. We've got to have the aldehyde to make it homologous, and we have to have these 2 methyl side chains. So it's just going to be this middle CH2 that we're going to change. And if we look at what we're going to keep the same, we have 4 carbons, but we need 20. So we're going to do CH2 times by 20, so we get C20H40, and then we just add it to what we're keeping the same. So our molecular formula when we have 24 carbon atoms is going to be C24, H48, and then an oxygen. To get the mark for this question, you need to write C24, H48O. Part B. Describe suitable chemical tests with observations that would confirm the presence of the functional groups in F and G. So the first thing we need to do with this question is identify the functional groups in F and G. So if we start with F, the functional group in F is this aldehyde group. So F/aldehyde, and the test for an aldehyde is going to be Tollens reagent. So we write Tollens and the positive test that we would get with the aldehyde, which is a silver mirror. Then we need to look at the functional groups in G. So G has 2 functional groups. It has a ketone here and an alkene here. So if we start with the alkene, so G/the alkene, because that's the functional group we're going to look at first. The test for the alkene is bromine water, and the positive test with the alkene present is going to be discoloration, or it's going to go colourless. And then we can look at G/the ketone. So the test for a ketone is 2,4-DNP. And if there's a ketone present, there'll be an orange precipitate formed. The alternative test to confirm that we've got G and not F is if we reacted G with Tollens, we wouldn't get a silver mirror, because 2,4-DNP is a test for a carbonyl group. So it would react with F and form an orange precipitate, but F with Tollens would form a silver mirror and G won't form a silver mirror. So to get the 4 marks for this question, you get a mark for your aldehyde test, a mark for your alkene test, and then you get a mark for each ketone test. Part C. Compound F reacts with HCN using NaCN and H+. Part 1. Outline the mechanism for the reaction of F with NaCN and H+, and state the name of the mechanism. The structure of F has been provided. Include relevant dipoles, lone pairs, and the structure of the organic product. So the first thing to do whenever you're given a mechanism question is to check the dipoles and put them on your reactant. So we're going to have a positive dipole on the carbon and a negative dipole on the oxygen of the carbonyl group. And then we have our Cn- that we get from our NaCN. And this negative Cn, or this nucleophile, is going to be attracted to the positive carbon. And then we're going to form an intermediate. So keeping everything else the same, so we have CH, CH3, CH3, CH2, because a lot of the time people get tripped up by messing up the first bit of the reactant. So it's making sure that you've got this completely correct and the same. And then we have C and a hydrogen. We have a singularly bonded oxygen now with a negative charge and lone pair. And we'll have our Cn bonded to this carbon. Now we react with our next reagent, which is H+. So H+, and this lone pair on the oxygen is going to be attracted to the H+, and we're going to form our organic product. So again, keeping everything the same, so our CH, CH3, CH3, CH2, and then we have a hydroxynitrile, so CH, OH, and Cn. So this is our organic product, and now we need to identify or name the mechanism. So the name of this mechanism, we have a nucleophile, so we can start by writing nucleophilic. And then you've got two choices, addition or substitution. Well, we haven't substituted anything in compound F, so we are adding. We've added this Cn, we've added this nitrile, so it's nucleophilic addition. And to get the 5 marks for this question, you get your first mark from your curly arrow going from the Cn- nucleophile or the nitrile nucleophile. You get your second mark for your dipoles being correct on the carbonyl functional group. You get your third mark for your second curly arrow, so going from the lone pair on oxygen to the H+. You get your fourth mark for having the correct organic product, so this hydroxynitrile. And then you get your fifth mark for correctly naming the mechanism. Part 2. Explain why the mechanism in C Part 1 involves heterolytic fission. So the first mark in this question comes from defining the word heterolytic. Heterolytic means that one bonded atom will receive both electrons, or 2 electrons in this case. Then your second mark comes from defining the word fission. So fission is the breaking of a covalent bond. So this is how the 2 marks are awarded, one for defining heterolytic and one for defining fission.